So this third FRQ on your review is about passengers on a train. So the number of passengers who boarded, a ship, not a train, is modeled by a differentiable function p, where t is the number of hours since boarding began. Values of p and t for selected values of t are given in the table. All right, and then this is a no calculator question. So A says, according to the model, what is the average rate of change at which passengers board the ship in passengers per hour? So we want to go on the interval from 1 to 8. So we only care about these numbers right here. So to show your work and show what you're doing, I think it would be a good idea for you to say that this is P of 8 minus P of 1 over 8 minus 1. And then go back on the table and find what P of 8 is and find what P of 1 is. All right, 8 minus 1 obviously is 7. 728 minus 35 is going to be 693. And that, luckily for us, divides evenly to 99 passengers per hour. Now we do want to write the units. Now it tells us the units, so that's good. But then you would go ahead and write them again. All right, and then for B. All right, B says to write P prime of 4.5 as the limit of a difference quotient, and then use the data in the table to approximate it. All right, so you have two choices for P prime of 4.5. There's two limit definitions for a derivative. So it's up to you which one to use. I am going to go ahead and use the second limit definition since we are finding this at an actual value. Now, if it was asking us to do P prime of x, we wouldn't have any other choice but to use the limit definition with the h. This one has just got a little less to write. So that's the answer to the first part. And it's important that you tell them what you're telling them. So it asks us to use a different limit difference quotient to write P prime of 4.5. So tell them that that's what that is. All right. The second part is asking you to use the data in the table to approximate it. So anytime we use the data in the table to approximate a derivative, it's asking us to find the average rate of change. Now, 4.5 is not in our table, so we would want to pick t values that 4.5 falls in between. And so the best ones are going to be the ones that are closest to 4.5. So we would do p of 6 minus p of 3. I need to go back and fix something. Over 6 minus 3. All right, I'll finish this one and then I'll go back and fix what I was talking about. All right, and then you can get P of 6 and P of 3 from the table. So 600 for P of 6, 204 for P of 3. All right, and so approximate value for P prime of 4.5 is going to be 302. Now what I did wrong is on this one, I used F. It is important that you use really what the function is called. Okay, so that is it. Let me see if there's anything else. Okay, I think that's it. for that one. All right, for C, must there be a time t between 3 and 6 at which P of t is equal to 500? That sounds like the intermediate value theorem. Oh, it's a good time to review that. That doesn't necessarily mean it's going to be on this test, but it's always good to review stuff. All right, the first condition of the intermediate value theorem is that the function is continuous. So it tells us at the beginning of the question that p is a differentiable function. So that tells if a function is differentiable, it guarantees that it is continuous. So because p of t is differentiable, p is continuous. All right. Second thing we want to do, let's see, our interval is between 3 and 6. So we want to find p of 3 and find p of 6. All right, so p of 3 is 204 and p of 6 is 600. Oh yeah, we just found this. All right, and then we want to check to see if the number we're looking for falls in between those two numbers, and we are looking for 500, and it does. So we would write that p of 3 is less than 500 is less than p of 6. And then finally, we can say that since p of t is continuous on the interval from 3 to 6, and p of 3 is less than 500 is less than p of 6, the IVT guarantees there is some value t on that same interval such that p of t is 500. All right, so the bell's about to ring, so I'm going to stop the video, but I will do one more video that gives the worked out answers for D on part 3.